quick intro. I'm a principal product manager on the Azure Machine Learning team here at Microsoft, and I've been working on some of the features related to collaboration and sharing of machine learning assets like models and pipelines in the product. I have with me two great speakers today for this session. We have Manuel from NVIDIA, and we have Gabrielle from Microsoft. Welcome to the session, Manuel and Gabrielle. Can you do a quick round of intro?
Yeah, hi. My name is Manuel Reyes-Gomez. I work for NVIDIA and integrating NVIDIA products into Microsoft. And thanks for being here.
Great. Gabrielle?
Hi, my name is Gabrielle. I'm part of the Gold Black Belt team for specifically artificial intelligence, and I've been working closely with Manoj and Manuel on the integration of NVIDIA through our customer experience.
Thank you. Before we dive in, quick rules of hygiene, please review the code of conduct that was shared in the chat. This is a discussion format of a session, so we take questions from the audience. So please leave your questions in the chat. I'm moderating the session and also looking at questions on the chat, so I'll keep a track of both of them, and I'll bring up your questions to the speakers as we proceed through the section through the session. We are going to get started introducing NVIDIA AI Enterprise, and then hear about Azure Machine Learning, and then we'll dive into a quick demo along the way. So let's get started. Manuel, can you tell us about what is NVIDIA AI Enterprise?
Yeah, thank you, Manoj. So NVIDIA AI Enterprise is an end-to-end platform for building accelerated production AI, everything powered by GPUs. It includes a library of full-stack software, including NVIDIA AI workflows, frameworks, pre-trained models, and infrastructure, which streamlines the development and deployment of production-ready applications for generative AI, speech AI, vision AI, cybersecurity, and more. It is comprised of several SDKs. Some of them have been integrated into an AzureML registry.
Great. That's a great set of toolkits out there. And then this session is all about using those toolkits in Azure Machine Learning. But let's quickly take a look at what is Azure ML. Gabrielle, can you tell us more about Azure Machine Learning?
Yeah, absolutely. So Azure Machine Learning is our platform where we allow developers from all kinds of stages to develop their own AI solutions, from a no-code to low-code to full code availability, with all the enterprise features necessary for training such large models, but also deploying it to experiments, basically everything that you would need to have in your toolkit in order to develop large-scale models, which we're also talking today about.
Great. That's good context. And in the title of the session, we touched upon registries. What are Azure Machine Learning registries, and how are they going to be used in the context of this partnership? Gabrielle, you want to take that one? You want to introduce the concept of registries in Azure ML?
Sure, absolutely. So registries are an amazing thing for, well, we have seen this already with a few of the other presentations, but registries actually allow us to do a combination of three things. So I can make specific recipes, what we also would call components and pipelines, that I would like to use within my own organization. I can do this on a company-wide organization, or I can use a third party, such as the one with NVIDIA. And what is great about this is that I then have access actually to all the amazing things that are available within that specific registry. So basically the recipes, which we call components, and the pipelines that allow me to reuse a lot of these capabilities from specifics. For the registry, what we're actually using here, Manuel, we have been working closely on creating what we would call the NVIDIA Community Registry. And it hosts all the different NVIDIA components and pipelines. So the packages that would allow you to reuse it in a registry that allow me to then make use of the different NVIDIA components through the SDKs that have been provided through the NVIDIA registry.
Interesting. Yeah, Manuel, you have done a lot of work on standing up this NVIDIA community registry. Why don't you show us this registry? Please walk us through that. Like, you have some demos for us today?
Sure. Yeah, I need to share my screen.
Okay.
Could you guys see my screen?
Yeah.
Great. Yeah. Okay. So we're starting with this beautiful being. So basically, first we need to navigate to the Azure ML portal, the Azure ML Studio, which will bring you to, in this case, to my latest workspace. In this is the place where you are doing all your work on Azure ML. So then basically we navigate, once we are there, we navigate to all workspaces, and then we go to registries. Once we are in registries, as Gabrielle commented, registries are usually made in order for you to share different Azure ML resources within your organization. So these are different registries that we have at NVIDIA that are only for people on my own tenant. But there are a couple of registries called community registries where everybody that is an Azure ML user can access. So let's go into. So this is the entry point of the presentation of the registry.
Great. So, Manuel, just to make sure I understand this well, this NVIDIA AI Enterprise preview registry that you're showing us here, this is created by NVIDIA, and it is available in Azure Machine Learning Studio, and it is available to Azure Machine Learning users. And this is not like really, the contents here are not really created by Microsoft. They are coming from NVIDIA. Is that correct?
Yeah, that's correct. Basically, well, as we commented before, NVIDIA has the NVIDIA AI Enterprise offering has several SDKs that do for several different applications, from computer vision, from NLP, natural language processing. Like, we have around 30 SDKs. So like what we have done is we have worked with Azure in order to make Azure resources of these kind components, environments, models, and data assets coming from our offerings. For example, environments. Environments are all the libraries that a particular piece of code inside Azure ML needs to in order to run. So here we have integrated a few of our SDKs. For example, Rapids. Rapids is a GPU accelerated alternative to Pandas and scikit-learn. Basically, using GPUs, and it could work at scale using Spark. Monai, for example, is an open source medical AI framework that unlocks the power of medical data to build deep learning models and deployable applications for medical AI workflows. We have Triton, which is an open source inference serving software that standardizes AI model deployment and execution and delivers fast and scalable AI production. Deepstream, that is a complete streaming analysis toolkit for AI-based multi-sensor processing of video, audio, and image understanding. And then we also have Tau, which we are going to explain later, because we're going to base most of our analysis on that. Then there are models, which are kind of self-explanatory, and data assets, basic. And then we have components. Components are another important part of the offering. So components are basically functional modular pieces of code that basically you could think of them as a function that run inside Azure ML and that can be interconnected to create a whole pipeline, a whole MLOps workflow that could solve a particular end-to-end scenario. Here we could see that we have different components that some are related to Tau, some others are related to Monai, some others are related to Rapids, etc.
Cool. So making sure I got this right here. You first showed us environments. These environments were packages, software packages of the NVIDIA AI toolkits, along with a Docker image that will help you run those toolkits. And then components are those specific commands available through those toolkits that you can run on those environments, right? Okay.
Exactly.
Great. How to use these? Like, it is great. They are showing up in Azure Machine Learning. I want to use them. How do I do that?
Yeah. So let me. I think it's the simpler way to explain this is through the. I mean, to start the idea is through the use of the designer inside Azure ML. So basically, here you could create your own pipeline using components that components that are available for in Azure ML. Then you go to the registry, and I mean here this one is choosing our registries, but we only want to use the ones powered by NVIDIA AI Enterprise. So let's start with a simple component. Let's say this is not been very fancy in the sense that is the download components. Basically, if you mouse over, basically it explains it's a component that is used to download data from the internet. If we look at the parameters, if you look at the parameters, basically you need to pass which are the URLs. You could pass several URLs where the data is that you're going to use in a particular workflow, and the data types. In this particular project, we're going to be talking. In this particular presentation, we're going to be talking about the Tau toolkit. Tau stands for Train, Adapt, and Optimize. What it does is it's a transfer learning toolkit, where basically it has a set of pre-trained models that you could take and then fit, customize a new model using your own data. So like basically it still uses it changes the weights, but it usually keeps the weights coming from the features that were learned from a vast amount of data, and then you only fine tune those weights in order to work better with your data with a relatively small set of data. So you could get a customized model with a lot less data that you will need otherwise. And yeah. Great. Oh, sorry. And then this component will download. I mean, the parameters on this component is which is the model type and the model name of the model that you wanna use from Tau. And later I'm gonna discuss where you could find all this information.
Great. So if I'm just getting started, you showed me like these list of components here, like 10, 15, 20 of them. I'm just getting started and I don't know how to connect all of these and create like a great machine learning experiment. Is there any way I can get started quickly?
Yes. So like we as we said, we were going to discuss about Tau components. Well, there is a concept called a pipeline component. A pipeline component basically is a way to specify interconnections between inputs and outputs of different command components, as we refer to these ones here. So this one here is a pipeline component. If I open it, we're going to see that it already has a whole bunch of different commands interconnected, and they're already set up for you to use. So here, for example, we could see that it makes sense that if the first component that we use is a component that is downloading the data. There's another component, as I was saying, that is downloading the required model from Tau. Then the data has to be pre-processed in this particular. Oh, sorry, I forgot to say this is the pipeline to recognize faces, and then eventually all this the data is passed into a train component that does the training and all. So here, so we have already, as Gabrielle was saying, this is like specified recipes that we use on how to interconnect the models, the components.
Great. So you have these recipes here as pipelines. What if I'm a power user or a data scientist and I want to go into code and I want to create my own recipes using these building blocks like train a model, download models, prune, like exactly. Using all of these, I want to be a power user and do my own stuff.
This is great. So we include when you are using the component, in this case the pipeline component, there is a link to a reference file which will bring you to a particular repo. this is a repo that where you could find we have different sets of data. So there are two main directories here. One is called source. Source will basically it has all the raw files, the YAML files, and the code that is used to power the resources you see in the registry. And so basically you could
sorry to interrupt here. What you're saying
Yeah.
is that all of the components and the nice things that you showed me, the code behind this is all open source. It's there in this repository.
It's all open source. It's all in the repo. You could see, and then it's all explained how is all that connected. Now,
Wow,
if you
okay.
wanna sorry.
Yeah, that's great. Yeah, sorry for interrupting. Yeah.
So if you wanna actually use it, how to use it? So there are two ways of using it. You could use using Python. You could run the components using a regular notebook, or you could use the Azure MLS CLI. Here it has all the examples. Let's focus on Tau as we were discussing before. And then here you could go to the README, and then it explains exactly what the pipeline is doing. It explains about the different components, how you prune the data, how you quantize all that. And it explains how you run it. It's very simple to run. You just need to specify in a config file what is your subscription ID and your workspace, and obviously you need to say you're using the registry, and then you just submit the job. It's very simple. So it's one line of code. But at the same time, there is all the explanations of what you need to change if you want to use your own data.
Great. So I can either go to designer, drag drop, and submit jobs that run this stuff, or I can like clone this repo and like dive deep into code and do all of these things programmatically. But yeah, that's great. I can't wait to see how you run these, and like, what did you get after running some of these jobs that train these models.
I actually have a few examples here that I could show you quickly. So this is here is an example of the task is detecting objects on a street. So when you submit the job, the job will be submitted. This will run, and then this is already done because it will take a few hours. But then let's quickly check out the parameters. So the parameters here are basically, as I was saying, this particular task is trying to detect cars, cyclists, and pedestrians on the street. So what we need to pass is, okay, what is the class the classes that we want to figure out, the URLs where you could get the data. In this case, you need to get the data. I mean, since we're retraining the model, you need to get some bounding boxes for some examples of how this will work, basically the images and the labels. And you need to specify what is the model you're going to download from Tau. Now, if I open, so this has already run. So this is a fairly complex pipeline because we wanted to highlight all the different things that Tau can do. Tau can basically, you download the data as you can see here, then you train, then we prune the data, then it gets converted it gets quantized. I don't want to get into all the details about that. But
yeah, hold on, Manuel. This is a big graph. Let's go step by step here. So you told me it downloads the data. That's good. Show me where it trains the model, and like, can I see what was the loss, or how did the accuracy improve? How many epochs did you do?
Exactly. So like the train model, if you were metrics, you could see like with the number of epochs, what is the accuracy that you get in your different the learning rate, sorry, and this is the loss, and then this is the mean average precision and the pedestrian precision. So you could get all that. Yeah, and then yes.
And did you evaluate? Like, can I see some sample results, like of some actual images?
So this component, the inference component, in the inference component, you could go to images and then see some of the examples. Let me get it a little bigger. Some of the examples of the bounding boxes that were produced by the model. And here, let me show you another one. So this is,
This is cool. So you showed us an example of detecting objects in images. How general are these? Like, let's say I know I want to detect human faces or like do something else. Are these very specific, or are these toolkits like generic that I can customize
let,
and
let
do
me
different
show you
things.
another example. But right before I go into that, I just want to comment on the last component. The last component is called Triton Create Model Repository. What this component does, it takes the model and it sets the model into the format that is expected by Triton. Triton, as I mentioned before, is the inference server, NVIDIA inference server that is implemented as an Azure, that is also implemented as an AzureML inference endpoint. So we have a similar pipeline like this that will take the output of this component and it will push the model all the way into as an AzureML endpoint, inference endpoint, so that you could have so that this pipeline goes all the way from data acquisition all the way to model deployment. So now
Great.
about your question, yeah. Sorry.
Yeah, hold on. Sorry, I'm interrupting again. That was super important for me. You said that this pipeline trained a machine learning model that can detect images, and the output of that pipeline, the model that was trained, you told us how you could inference that, right? Like you take that model and deploy it to online endpoint, and then like how do I score it? Like, do I get a REST API or like
Yeah,
how
you
do I
get a
use
REST
that in my
API where
apps?
we have examples on the repo that I showed before. We have examples of how you will use it. Basically, you deploy it, and then you get back you get back a URL, a REST API where you could send requests. Basically, you send images, and then you get answers from the API, and the answers from the API are going to have the bounding boxes. Then, of course, then you will need to deal with them according to your application. But we have all that in the repo. So in the case that, okay, let me show first, before we go into how will you use it in your own data, let's look at another example. So this is another example. It's another pipeline that is also there in the. So first, let's quickly look at the parameters. So in the parameters, then we could see that now what we're trying to detect is faces. So we're trying to detect a face. Now, obviously, the URLs are different because we're using different data. And then let me close here. And then let's look at the pipeline. Oh, sorry, it's here. So this is a little less complex, but the important thing is that we are exactly using the same components that we use for the strip object detection. We still downloaded the data. We still downloaded the model. We're using the same ideas that we're using training. We're pruning the model, but the components are exactly the same. The only thing that changed was the input. In the case, the input data that we're going to use to retrain the model, and the base model we're using for Triton from Howell. But at the end, like if we want to see the results, we still have the same components, but now what we get is what we're detecting is faces. So like using a very similar template with very similar with the construction of the interconnection of the modules is exactly the same. Basically, we have a training model where we need to plug a pre-trained model. We need to plug some new data, and then that output we could decide to prune it or not prune it or whatever. But if you decide to do it, the pipeline is exactly the same, and it's exactly the same components. And with this, I'm finished with the demo.
Yeah, this is awesome. All these toolkits, they are so easy to run on Azure Machine Learning now without having to go through all the effort of importing those toolkits on the machine learning Azure Machine Learning platform. Yeah, Gabrielle, you have worked with a lot of customers who use Azure Machine Learning and are also interested in these AI toolkits from NVIDIA. Can you tell us a little bit about how this helps your customers to get to production fast?
Yeah, absolutely. So I think what we see currently, I've worked with a few customers alongside with you on the private preview for this, where the key of this is really, hey, I want to be able to bring my components that I've created for my own company to productionize some of my models, very fast. I want to combine them with specific components from NVIDIA, such as NeMo, such as like Towel Toolkit, as what Manuel has shown. And I want to be able to reuse them throughout my organization. I also want to be able to actually say, hey, Manoj, I have this amazing model that I've created through the NVIDIA, and I actually think it would be great for your project as well. What it allows me to do with the components, the registry, and also the pipelines, I can actually share it with you. You can see exactly what I did and say, oh, I will just change my data. I will change your data set with mine, and I can just retrain it, or I would like to make some changes, like small changes, saying I would like to do less epochs. And you can do that all together in a very easy way. You don't necessarily have to go through a lot of lines of code. You are able to reproduce the results quite fast and also share them and also expand them according to your needs.
Interesting. So what I took away was that getting started is very fast. Citizen data scientists, low code, no code personas are welcome, and at the same time, it is also for power users who want to fork and customize things. That's great. We have a question from the audience, and I think Manuel, this one goes to you. You showed 2 pipelines, and one for object detection and one for face detection. The question is about how similar or how different were these pipelines?
I mean, it's a very good question. I mean, yeah, we could say that they're basically the same pipeline. It's just like we call them differently because you end up with a different model. I mean, the model type is different, but in essence, the pipelines are the same. Well, the only thing we're changing are the inputs and the inputs in the sense of the data that you're using to train, and the model, the base model you're using to do the training. But in essence, they are the same. Yes.
Got it. Okay. We have few minutes left. We can take questions from the audience, if any. So feel free to ask your questions in the chat, and I can pick them up. In the meantime, what I have seen is that NVIDIA AI has more than 20 or 25 toolkits available today. But you spoke about 3 to 5 toolkits that we are onboarding. What about the rest? And Gabrielle, do you think that there are other toolkits that our customers are asking? And Manuel, to you, how do you plan to prioritize the rest of the cool stuff?
Yeah, so shall I start, Manuel?
Yeah, sure. Go ahead, Gabrielle.
We see already quite some requests coming in, very specific. So I think one of the first ones that we're now actually working on together, Manuel, is actually Nemo. Nemo is something that we see a lot of uptake happening within large enterprises that are looking into training their own LLMs. It's one of those SDKs, but I think we shouldn't also forget the ones that are already available, such as Rapids. I absolutely love Rapids within the components and within Azure Machine Learning because it's such a great tooling to use for pre-processing your data when you want to do that at scale with GPUs. So, if you have any requests, people in the audience, feel free to kind of reach out and say, hey, we would love to see this SDK from NVIDIA because that allows us in essence to prioritize accordingly.
Great. We are close to the end of the session. So folks, if you're interested in trying this out, this is currently by invitation only. Very soon it will be public preview and open to everyone. But we are looking for early adopters to try this out and give us feedback. So the session, so the URL where you can go and sign up for this, I'm flashing it on the screen right now, and we'll also ping it in the chat. With that, I think we are at time, and I would like to thank Manuel and Gabrielle for sharing all these interesting insights with us, and looking forward to you folks trying this out and giving us feedback. Thank you, one and all.